Okay, let's dive into this. Welcome to this explainer where we are focusing on exactly what you need to know for the NCP-MCI 7.5 exam, specifically Objective 1.1, Foundation the Deployment Engine. If you're an infrastructure admin stepping into the Nutanix ecosystem, Foundation is literally your absolute starting point. It's the gateway to your day zero operations. We're going to cover everything you need to know about this tool, how it interacts with different node states, and the exact rules of engagement you need to memorize to ace this portion of your exam. Our agenda for this study session maps directly to the exam blueprint. We'll cover why Foundation matters, node factory states explained, deploying versus expanding clusters, common exam traps, and finally, those key facts to memorize. Section 1. Why Foundation matters. To really wrap our heads around this, think about the journey of a node. When bare metal hardware rolls off a delivery truck, it's essentially just an expensive box of metal, processors, and drives, right? Without a deployment engine, it totally lacks the intelligence to participate in a converged scale-out storage system. Basically, it needs a brain. And that brings us to our first core definition, AOS, or the Acropolis Operating System. AOS is literally the brain of the Nutanix cluster. It's the operating system that runs inside the Nutanix controller VM, or what we usually just call the CVM. Every single node in a Nutanix cluster absolutely must have a CVM running AOS. This is what provides all of that Nutanix-specific magic. The data localization, the storage pooling, basically everything that makes the infrastructure invisible. And this brilliantly illustrates the architecture. Notice how the controller VM, running AOS, sits inside every single node. It's positioned right above the storage hardware and right beside the guest VMs, so it can easily communicate across the entire cluster. So the golden rule for your exam is this. For a node to join a Nutanix cluster, it absolutely must have a supported hypervisor installed, plus that controller VM running AOS. Without both of those components, no way. That node simply cannot participate in the cluster. Okay, the second definition you need to lock in is AHV, or the Acropolis Hypervisor. This is the native Nutanix hypervisor. It's the layer sitting right there directly on the hardware, and it actually hosts that controller VM we just talked about, along with all of your user guest virtual machines. Now, while Nutanix does support other hypervisors, AHV is the native choice, and it's the default for Nutanix factory nodes. Foundation's job is actually very often to install this exact combination, laying down AHV as the hypervisor and then spinning up the CVM with AOS right on top of it. Section 2. Node Factory States Explained. Now pay close attention here, because the distinction between these three factory origins is highly testable material. First off, if a Nutanix node is shipped inside the USA, it arrives pre-imaged. This means it already has a hypervisor, typically AHV, and AOS installed right there from the factory. Done. Second scenario. For shipments outside the USA, due to various international export rules, Nutanix installs a lightweight piece of software called DiscoveryOS. It is not a full hypervisor, it's really just there to allow the node to be discovered on a network. And third, if you're buying from a non-Nutanix OEM, so a third-party vendor without a direct imaging agreement, that node arrives completely bare metal. No hypervisor, no AOS, not even DiscoveryOS, just totally empty drives. Section 3. Deploying and expanding clusters. So, the crucial point is, to really master this objective, you need a rule and exception framework for our two main tools, Foundation and Prism's Expand Cluster. Foundation is your heavy lifter for day zero. You use it to form brand new clusters, and critically, it has the ability to perform bare metal imaging. It can literally take a completely blank node and install the hypervisor and AOS completely from scratch. Expand Cluster, on the other hand, that's a day 2 operation tool that you find inside the Prism interface. It is used specifically to add nodes to an already existing running cluster. But, and this is a massive limitation that they love to test on the exam, Expand Cluster cannot perform bare metal imaging. It absolutely needs at least some software on the node to talk to first. Let's look at our first concrete example, new cluster creation. Just imagine you've just unboxed 3 brand new nodes. They might be US pre-image nodes, or maybe they're international nodes running DiscoveryOS. Either way, because no cluster exists yet, you must use Foundation. You'll launch Foundation, let it discover the nodes on the network, and then use it to either configure the existing software or re-image them with the specific hypervisor and AOS versions you actually want. Once they're imaged, Foundation seamlessly groups them all together and forms your brand new cluster. Foundation is the engine from start to finish here. Now, for example 2, which requires a bit more thought. You have a running cluster and your company buys a bare metal, non-Nutanix OEM node that you need to add to it. You might naturally think, hey, I'm adding to a cluster, so I'll just use expand cluster. But remember the rule. Expand cluster cannot perform bare metal imaging, so you're looking at a two-step process. Step 1, you absolutely must use Foundation first, solely to lay down the base hypervisor and AOS on that blank node. Step 2, once the node finally has its baseline software, then you switch over to Prism and use the expand cluster tool to officially ingest that node into your existing cluster. Basically, Foundation preps it, expand cluster adopts it.
Section 4. Common exam traps. All right, here is a classic mock exam scenario. Read this carefully. Can you use expand cluster to add a bare metal OEM node to an existing cluster without using Foundation? Think about the software state of a bare metal node and think back to those stated limitations of the expand cluster tool we just covered.
The answer is a definitive no. This is the exact trap we just talked about, but presented as a direct question. If you select yes on the exam, you are gonna lose those points for sure. Expand cluster fundamentally does not support direct bare metal imaging. Softwareless nodes literally must be touched by Foundation first just to get their hypervisor and AOS, and only then can expand cluster step in and do its job. Seriously, burn this rule into your memory.
Okay, let's try another trap scenario to test your understanding of that international shipping exception. What tool is required to add a node running DiscoveryOS to an existing cluster? Remember, DiscoveryOS is lightweight. It's not a full hypervisor or AOS. So does it act like bare metal, or does it have its own rules?
Let's move to and see how this builds, because here is the exception to the rule. Unlike bare metal, DiscoveryOS actually has just enough intelligence built in that both tools can work with it. The source material explicitly states that both Foundation and Expand Cluster allow you to directly image a DiscoveryOS node with the correct hypervisor and AOS. So, if the question asks what tool can be used to add it to an existing cluster, Expand Cluster is a perfectly valid and correct answer, simply because it can image right over DiscoveryOS.
Section 5. Key facts to memorize.
Now, what's really interesting about this slide is, well, you should consider this your ultimate cheat sheet for this subtopic. Seriously, pause the video right now and take notes if you need to. Fact 1, every node must have a supported hypervisor and AOS running on a CVM. No exceptions. Fact 2, Foundation is your day zero tool. It forms new clusters and is literally the only tool that can image bare metal. Fact 3, Prism's Expand cluster is strictly for day 2. It adds nodes to existing clusters, but absolutely cannot image bare metal. Fact 4, know your factory states inside and out. US is pre-imaged, international is DiscoveryOS, and non-Nutanix OEMs arrive bare metal. So, as we wrap up this explainer, I want to leave you with this question to ponder. Are you confident you can identify the exact deployment tool required for any given node state on the NCP-MCI 7.5 exam? If the exam throws a bare metal node scenario at you, do you know your first move? If you've internalized the rules and the exceptions we just went over, you are well on your way to mastering Objective 1.1. Keep reviewing those factory states, trust in the rules of Foundation versus Expand Cluster, and go ace that certification.